My name is Marcus, and this is my project demonstration screencast for the TDDD27 Advanced Web Programming project. So first of all, let's just take a look at the application I built. What you can see up here is a live preview, and what you can do is you can type something in here, Advanced Web Programming, and what shows up here is a video based on the text inside of the text editor. And if I add something new, it's going to update live. So let's do that. See? What you can also do is you can change the slide type. It's kind of a slide type video. And what you can also do is you can change the background color. So let's do F00, which is red. Oh, image. F00. And you can also have an image. So let's take this image right here and paste it in. Go over to that slide, and you can see that it's animating the image and it has the image background. So we've got this heading, this paragraph, and then the final image slide. Let's stop the project. The first thing you see here is that I'm running this using Docker Compose. So if I run Docker Compose, it'll start all of the web services. And notice the order. We have Redis here, we have producer, worker, and web. Remember that order, so let's jump into the project. If we jump into the Docker Compose file, we can see we have a few services. We have Redis, worker, producer, and web. Redis is right here. It's just a Redis instance, a basic Redis instance. This doesn't have anything in particular that's specialized to this project. We have a worker. The worker depends on Redis. The producer depends on Redis. And the web service depends on the producer. So since both of these depend on Redis, Redis will start first, and then these two will start secondly. And finally, the web service will go live when the producer has started. Another thing that this project uses is NPM workspaces. And you create an NPM workspace by creating this package JSON file and adding the workspaces property. And this says that anything inside of the packages is a NPM workspace package. What this does is that, for example, in the web app, I can require something, a package, that is inside of this workspace. So this package is called Remotion Source. It contains the source video template for the video that you previewed that you saw, and it's version 1.0.0. This is important. You have to use the exact same name and the exact same version, but that way we can use it in different services. This one doesn't depend on it, but the worker does depend on it. You can see right here, Remotion Source. And that way we can share this code between different places inside of our multi-service project. So what services do we have? We have the web app, the worker, and the producer. The Remotion Source is a library that contains the video template. Each of these projects is written using TypeScript, and if we have a look inside of the index page, you can see it has an extension of TSX, and you can use interfaces in order to get better auto completion. So if we take a look, we have a render state here that uses a React state of render state value, so we can see, oh, it's a render state. And if we type something, render state, we get auto completion. And this is really nice. If we type something that doesn't exist, we get an error telling us that that's what happened. Now that we're in the web app project, we can talk a little bit about the web app project. It uses Next.js and Tailwind CSS. That's the basics. So Tailwind CSS is a CSS utility framework, and it adds a bunch of CSS classes like this one, MT4, margin, top, and size 4. If we hover that, we can see that's 16 pixels. We can add flex, turn it into a flex column, and center those items inside of the flex column. Next.js is a framework for building web applications with React, and it comes with a few nice things like a dev server, and you can deploy it to production with their server. And another nice thing is it has file-based routing. So inside of this source directory, any file we create inside of Pages becomes a route, except some special case files like this app _app file, which wraps any other route. So the way I'm going to present this is I'm going to first show a little bit about the structure of the front-end application, since that's what we're interacting the most with. And then I'm going to show more about the video side. And finally, I'm going to talk about the text editing experience. So inside of this Next.js route page, the index page, which maps to the root of the website, we have basically the entire application interface. This renders different states depending on what's going on in the application. So when we get into it, it's initial or it's in a failed state. And when we're in those two states, it'll render this video preview and the editor plus this button that converts to video. When we press the convert to video button, it goes over into a state called submitting or rendering. And while it's submitting or rendering, we get a UI that shows a cancel button and also a text that says that we're creating a video. And finally, if we're successful in the successful state, it'll show a video of the finally rendered video that you can download, or you could also start over. And starting over will set the render state back to initial, and we'll get back into the initial render state. So what's inside of this initial render state? If there was an error, it'll display this error. And the second thing that exists is this preview, the iframe player that is showing our live preview of the video we're editing. We have the convert button, and we have the text editor. Since we'll talk about the text editor and the video later, let's take a look at this do convert button. It has a callback called do convert, and when we click that, we go into this function. And this function will set the render state to different things, submitting, failed, for different cases. So let's go through what's happening here. The first thing is that we try to post the data for the job, for the video, into this jobs endpoint on the back end, which we'll look at a little bit later. And if that doesn't work, we failed. And then we'll try to get the response data out of the response. If we can't get that, we'll set the state to failed, and the UI will go back to the initial place and show this error. If the response wasn't okay, we also set it to failed. Otherwise, we pick out the video ID out of the data. We remember that the render started now, and then we set the state to rendering. What we then do is we wait for the video URL to show up. And we do that by awaiting a promise. And what this promise does inside is it has this check render function. And what that check render function will do is it'll ask the backend for the video ID job. And if we can find a URL inside of that, this public URL thing will resolve the promise. Otherwise, we'll try again, and it'll try doing that for, let's see, max retries for 200 times before it gives up and says it took too long, and we failed. If nothing bad happens all the way down to the bottom, we'll set the render state to successful with the video URL. And now I realize we never actually return the video URL, but it doesn't matter because we always read this video URL out from the render state anyway. That's the base of the app flow. So let's have a look at the video parts. My video is a component we're going to look at later, but in short, it's a remotion component. And if we go to remotion.dev, you can see that this is a library for creating videos by making web pages. In short, you create a React application that mounts something, and then you can read out the frame and react to and to animate and place things based on that frame. And then Remotion will take that and render that inside of Puppeteer, which is a Google Chrome that you can program. It'll take a screenshot of every single frame, and then it'll stitch that together with FFmpeg. So what we had here, this is our component that will render whatever we have inside of our document. And our document is, right now we type it because sometimes types are a pain, and in this case they were. But the document contains the editor state transformed into something that can be rendered by our template that we built. Inside of the editor state, we have a bunch of information. We've got a tree of all of the text and all of the nodes that exist there. We'll take a closer look at that later. But for now, you can think that the editor state comes in, and then it gets transformed into something that the template can render into something. And we set it, and because we set it, React re-renders, and inside of this input property, it'll get the new values plus some other values like what FPS it is, how long the video is, how big it is, on and on. And it'll use that to render the preview. But here comes one challenge. Since Remotion is just a normal React component that's mounted in, I've created this iframe player component. So if we go into this iframe player component, you can see that there is a player component inside of Remotion. But this player component will be affected by anything that exists on your front-end application. So if you remember, I used Tailwind CSS that had a bunch of utility classes, and it also has CSS reset. So anything that Tailwind puts into the global CSS will also affect the video. And that's not what I want. I want the CSS inside of the video template to be separate from the CSS that is on my application. And one way of doing this is to wrap this player inside of an iframe. And that's what this component does. Basically, it creates an iframe, and then it gets a reference to that. It uses the let's see here. It uses this state thing. So as soon as it gets this content reference, it'll re-render, and we're watching this as well. And it'll see if it can get the content document inside of the iframe, and then it'll get this mount node, and the mount node is the body inside of the iframe. And once it has that, it'll create a portal, which in React is a way of rendering something somewhere else in the DOM than in that particular place in the tree. And an iframe body is not inside of that tree per se, so this is the way you would do that. So we mount this player component, we pass in the props, and then what happens inside of this effect is that if things resize, it'll also resize other stuff, so everything stays in sync. Now with that out of the way, let's take a look at this component, my video. Oh, we jumped into the types. Let's do this by going into the packages, promotion source, and inside of here we have my video. Let's minimize most things and then talk about them one by one. So if you remember that editor state that got transformed into a document, this is what that document looks like. So the document is an array of document items, and we can see the base document item has a type, which is custom paragraph or heading. It also has text inside of it, which is just a text string. It has a background type, image, video, and solid. I've only implemented image and solid. And then the background value will be whatever value you want to use when you're rendering this document item. So for image, it would be URL. And for solid, it would be a CSS string representing a color. So it would be a hex color or RGBA, or just the word red works as well. Now let's take a look inside of what's inside of this actual React document. It takes that doc that we just talked about as a prop, and then it creates a little bit of CSS. So this is a CSS reset. The most important thing here is setting a base font size for the document. So all of the EMs and REMs look good are relative to this base size. We're making a 1920 by 1080 video. And the way I've done it here is that if we get the width from the video config, this is a remotion hook, so it gives you information about what size and what frames per second and how long the video is and all of that stuff. So we take the width, which in this case is 1920, and multiply it by some factor in order to get a base size that feels good when we're working with the template. So 1920 by 0.02 is 38. So anytime we write one REM, we get a 38 pixel size. And we can use that for margins and paddings and text sizes and whatever we want to use it for. Moving on to what's being returned. Here we can see those CSS strings are being mounted. And then inside of here, we're taking that document, which was a list of document items, and we're saying that what we want to return from this reduce is either a document item or a transition item. So for the first index, we just return the item. So in our case, that first thing we wrote, TDDD27, that was a header, that'll show up there. And if it's not the first item, we'll let it have all the previous items and then also a transition item followed by the item. So if we have in the text editor, if we have a heading and second thing and final paragraph, we'll get one of these items. Since this is the first one, it won't add a transition, and then in between we'll get a transition and then a paragraph and then a transition in between and then the final paragraph. And that is done inside of the next map where we switch. So if we have heading, custom paragraph, or transition, it'll return those types. So now let's take a look at one of these components, one of these things that actually render something. Here's the heading. And inside of that heading, we're getting the current frame in the video. And then we're using that to calculate a translation and an opacity for the text. And we're adding that translation and the opacity to a div. This absolute fill thing will create a div that fills up the entire video, the entire space of the video. And we also have a background component that'll also look at the frame and it'll scale the background. And if the background type is an image, it'll place that image onto the stage, and with this image component that's from Remotion, and this component will wait until the image is loaded before it renders the frame. One of the things that I haven't talked about yet is these interpolate functions, and this is the secret to animating inside of Remotion using this frame property. So interpolate takes takes the frame. It doesn't have to be the frame, it can be any value. And then you pass an array of values that we're that we're interested in. So when the frame is 10 and when the frame is 40, in between there, we're going to interpolate. So the next one is, what will the values be? So if we have frame 10, the value will be 1. And if we have frame 40, the value will be 0. And everything in between there will be interpolated. So it'll go from 10 to all the way up to 40, and it'll do the same thing. So this is the output values that you'll get. And then we have an option object. And inside of that, if you don't want it to ease linearly, you can use another easing function. And then what happens if the frame is less than 10 or bigger than 40, then we have different things we can tell it to do. We can tell it to extend or identity. I don't know what that does, but I usually just use clamp, which means that, well, if it's less, then just return whatever it is, then pretend like it's 10. And if it's more, then pretend like it's 40. And the same thing happens over here. So we have an opacity that goes from 0 to 1 between frame 10 and 40, and we have a translate Y that goes from 1 to 0 between 10 and 40. And Y, when it's bigger, you have things further down on the page, and opacity, when it's nothing, you don't see anything. So what happens here, it goes from 1 to 0, so Y goes from something further down to something further up. And if we take a look at what this looks like, yeah, you can see it right there. It goes from the bottom up, and it goes also from opacity 0 to 1. And that's basically how animating things in Remotion works. A final thing I'm using here is a library that I wrote for Remotion, which is called Transition Series. Remotion has a component called Series, And inside of series, you have a sequence component as well. And what this does is it just places the things after each other in time. And you can say how long this thing is. So the heading is 120 frames, and then we have a transition that's 15 frames, and then we have a paragraph that's 120 frames. So it'll place them after each other. It's up on my GitHub if anyone's interested in taking a look at it. But one interesting thing we could do is just take a look at what the transition actually does. So this is an example of an implementation. So this transition, the fade transition is the default. It'll receive the progress, and that's between 0 and 1. So on the first frame, it'll be 0, and on the last frame, it'll be 1. And then we'll get the exiting element and the entering element. So in between here, in between these two, here we can see them both at the same time. So the heading is the exiting element, and the paragraph second thing is the entering element. And what we do then is we place the exiting element, and anything that's absolutely positioned and placed afterwards in HTML will be rendered afterwards. So it'll be rendered on top. So the entering element is rendered on top with progress as the opacity, and progress goes from 0 to 1. Now let's take a look at the back end. We have this producer, and it's a simple Express server, and it also uses bool MQ, which is something that interfaces against a Redis database or a Redis instance in order to be able to do a job queue. So we have some Redis connection options, and we create a queue with those connection options, and we also want to subscribe to the events on these options. And the events are waiting, active, completed, failed, and progress. And all I'm doing here is I'm just logging this out to the console. But let's scroll to the bottom. So we have our Express application, REST application, listening on whatever port we specified. It has a post endpoint /jobs where you can create a job. So you send in render data via the request body. So whatever that doc items that existed on the front end, we'll send it back, and it'll create a job and then return that job as JSON. And then we have a get endpoint that takes an ID, and what it does with that, it picks out the ID, and then it gets the job with that ID, returns a not found if that job doesn't exist, and if it exists, it returns whatever's inside of that job, the data from the job. And this endpoint is used by the front end. It polls the back end and asks it over and over again, is the video done? Is the video done? Is the video done? Is the video done? And then when you finally have a public URL, the video is done, and it stops asking about it. The other part of the backend is the worker. So if we go into the worker, this is also a Node application, but it's not an Express application. We don't import Express, but we do import some stuff from Remotion that has server-side rendering, and we also have bool MQ. We have Supabase, which is a backend as a service. In this project, we use it to upload the video to storage, so you can download it and view it from the front end. So if we take a look here at the top, there's just some startup going on. We continue the startup by creating our Supabase client. The composition ID this is something that exists inside of the Remotion source. So if we look at compositions, composition ID, mycomp, this will be important later because it'll try to find the comp to render. So this is really a global variable. We have our init function, and this init function will find the bundle path. It'll get the built source inside of Remotion source over here, and it'll pass it into Remotion's bundling function. And this is what bundles everything up and creates a file that the Remotion renderer can use to render things. And inside of this composition ID exists. So what we do on startup, it goes all the way down here into the init function, and once it's built this bundle, it sends the bundle on, and we create a worker and connect to that same Redis instance as the producer is connected to. We wait for render jobs, and as soon as one show up, we send it off to this process job function. We send the job data and the bundle location, which is kind of the video application that the Remotion renderer will use. So when a job comes in, it tries to render it, and if this returns without throwing an error, then the job is considered to be done. And if it does, we just throw the error again. So let's have a look at what happens inside of this process job function. So we get the job data and the bundle location. We get out the input props that we sent from the front end, and we send those into this get compositions function that takes that bundle, and it looks inside of that bundle, passes in these input props, and it gets all the compositions that exist. Right now we have just one composition inside of this compositions thing, the mycomp one. And then we try to find that composition ID mycomp. If we don't find it, then we can't render anything because we don't have a template to render. But if we do find it, we prepare to do the rendering. So we prepare what we want the file to be named, and then where it should be located on this server instance. Then we have a progress updater that'll update the job with the progress happening so we can get some feedback. It's not actually implemented in the front end right now. And then we log some stuff to the server logs. And after that, we just send it on to Remotion's render media function that takes the composition that we found. It takes the bundle that has that composition inside of it. We want an H.264 video. We want the output location to be what we wanted it to be, and we send along the input props. And the rest of the stuff here is just logging, so we see that something happens inside of the browser logs. And if this finishes without any problems, then we know that there is going to be a video at this location. So what happens here is we print some stats to the logs, and then we read this file. And once we've read it, we try to upload it to Supabase. If there was an error, where we remove the file and we throw the error. If there wasn't an error, then everything was uploaded, and we can get the public URL from the Supabase API and update the job with the public URL. And if you remember, the front end's waiting for that public URL to show up. So once that shows up, then the front end can update. And the final thing that happens here is that the file is deleted from the worker service. it still exists inside of the Supabase storage, so the front end and the user can download it. And that's pretty much how the rendering of the video works. And finally, let's talk about the text editor. Let's go into the front end. Let's go to the base route. Here we have the text editor. There's a lot of options for different text editors, but lately there's been a library released by Facebook called Lexical, and it's a text editor framework that you can basically build text editors with, and it's very Reacty. So you compose things, and it has a lot of reference implementations for React, which is really nice when you want to build something like this. There are other options, but I went with this one this time. In order to explain Lexical, let's go to their playground. This is something that's built with Lexical. Anything inside of Lexical is a node. So there's tons of different nodes like this. Mention is a node. This bold text is a node. The hashtag is a node. You can add in, let's see here, you can add an equation, x plus y equals 3y, and it's added inside of here. And there are 3 different types of nodes that you can extend. An element node is a node that is used as a wrapper for something else. So things like a heading would be an element node, and this block quote would be an element node. And they can be inline as well, like let's see, like this one. But they can also be block level. And then there's text nodes, and these are the things that actually contain the text. And they have some properties also, like they have formatting, like bold, but you can also extend them to be specially styled when you have certain types of patterns, like hashtags or @ mentions. And the final one is called a decorator node, and that's for inserting something that's not text. And the equation is a perfect example of this. It now turns into an input, and when you don't focus on it, it's a rendered LaTeX equation. So if we take a look at the editor here, what I have is a heading and a paragraph. So what I've done is I've extended the element node because I want to add context to these things inside of the editor. I want them to be a heading or a normal paragraph, but I also want to attach this information, the color or image information, including the value of that. So let's take a look at the editor. So let's jump into this. And inside of here, this is a lexical thing. So we get a lexical composer. And inside of this lexical composer, we have what they call plugins. And the plugins, they'll do various things with whatever is inside of the editor context. They have reference implementations for rich text and plain text, but I wanted to keep things simple for the user, not for myself. So I implemented a custom text plugin. Usually, if you just wanted plain text or rich text, you would use one of their built plugins. But they also serve as great references for creating your own things. So certain things that I didn't want is I didn't want you to be able to indent text. So what you do is you create your own, let's see, We have this register custom text function that takes the lexical editor, and then what you do is you register a ton of things. And most of these things come from the rich text editor. But for example, here, I've commented out the indent content command. And that's because I don't know at this moment what indentations would mean for the video, so I take that functionality out. However, I want to be able to attach that metadata, that background information, if it's a solid image, or if it's if it's a solid color or an image. So in order to do that, I extend the element node. If we remember, that's the thing that's supposed to be a wrapper around other things. And I create this new node that has this background attribute, and you can in here you can get that background, and you can set that background if you get a handle to this node. And again, a lot of this is copied from their reference implementation of the rich text editor that has a heading node. So I've used that to create these specialized nodes for my application. The other node is a custom paragraph node. Also extends the element node and also has the background. Both of these really could have used a same base class, say my custom text editor element node, but right now it's just duplicated code just because that was faster this time. And in order to use these, you tell the lexical composer that your editor has these types of nodes. But there is one issue though. Paragraphs, they're a native node to lexical. So I don't want there to exist a paragraph node and also my custom paragraph node. So in order to make that work, we go into this, and I've registered a command or registered a node transform that whenever it sees a paragraph node, it replaces it with a custom paragraph node. And this custom paragraph node function, it's just a function that exists inside of this custom paragraph node. And the denomination is just a convention in the lexical framework. You can go on the documentation and read why they did that, but I've kept with whatever their best practices. So now we have an editor that can have headings, and they can have custom nodes, custom paragraphs. But there's also this toolbar over here. And once again, looking at the reference implementation of the rich text editor, I created this toolbar plugin and took out things that I didn't need and added things that I did need. As you can see, there's a bunch of options inside of their rich text editor that I wasn't interested in, but I was interested in adding background type and background value. So let's look at the render, what this React component returns. So it has two button groups. If we take a look, we've got the type, and then we've got the background, including the background value. So if we click it and we hit the heading one or the custom paragraph one, we run the functions format heading or format custom paragraph. And if we are inside of the background button group, we do the on background type select and on background value changed. And what these do is they have a callback, they get the value, and they pass it on to this apply background function. And this one is very similar to the format custom paragraph and format heading. And all of these functions, they're quite a lot of code, but in general, what they do is they make sure that you have a range selection, then they get the nodes, and then they make sure that, oh, is it the right type of node? So is it a custom element node? And then it figures out, oh, if it's a custom element node, then you're able to use this get background method that existed on these extended classes. And what it does is it sets the background on them. And finally, what we also have is this onChange plugin, and this is one of the built-in ones that exists in Lexical. And what it does is it calls a callback as soon as there is a change, and that callback just passes that along to the onEditor state change. And if we go back to the page where this one's used, we have the onEditor state change, passes it to the callback handle editor state change, and we can have a look inside of there. And what it does, it gets a handle to the editor state. It reads it, and then inside of here, it's safe to get the state. We log it, and then we go in and we transform the text document, the lexical document state into something that can be rendered by our video. And that's pretty much all of everything. We can maybe we can render a video to see everything happen again. Let's take one of these. Oh, it's a color. That's not going to work. Let's move over to image, like that. Take a look at our video. We've got a heading, and then a paragraph with a background, and then a paragraph with just the default color background. We click Convert to Video, and now we can see all of those logs. Let's move this window down a little bit. And then it uploads it. Now it's done. And this is an MP4 video now. If we inspect it, we can see a video, and it's actually an MP4.